Hi everyone, welcome back to our channel. Today we are going to find the solution for this problem. The given problem is apply voltage division rule and find the voltage across 6 ohm resistor. Okay, so the voltage across 6 ohm resistor and find the voltage across 9 ohm resistor and find the voltage across 5 ohm resistor, and we can verify the KVL also. Okay, and verify KVL. Okay, so now I'm going to use the voltage across 6 ohm. Okay, so here voltage across 6 ohm resistor, the formula is total voltage or source voltage into same resistor where voltage is required divided by the sum of resistors which are connected in series connection. I can say that 6, 9, 5 are connected in series connection. Therefore, the formula, if you apply, what is the total voltage given in the problem is how much? 60 volts into same resistor. Across which resistor we want the voltage is 6 ohm. Same resistor is 6 ohm divided by the sum of resistors which are connected in series. You can see here the same current flows in the three resistors. I can say 6, 9, 5 are connected in series. So then I can write down 6 plus 9 plus 5. So similarly, when you solve it, this is 60 divided by 6 plus 9 plus 5. You may be getting the voltage as 18 volts. Similarly, we are going to find out the voltage across 9 ohm resistor. So what is the formula is total voltage or source voltage. Source voltage is how much? 60 volts into same resistor where voltage is required. At which resistor we require the voltage is 9 ohm. So that's nothing but 9 ohm divided by the sum of resistors which are connected in series. 6, 9, 5 are connected in series. Why? Because constant current is flowing. Okay, so it's nothing but 6 plus 9 plus 5, that is equal to 27 volts. Similarly, the voltage across 5 ohm resistor. What is the formula? Total voltage. What is the total voltage? 60 volts into where we require the resistance is 5 divided by the sum of resistors is 6 plus 9 plus 5, that is equal to, we are going to get it as 15 volts. Now 18 plus 27 plus 15. So you will get it out how I am going to apply the KVL. Okay, so when you are going to apply the KVL, so the network is like this. How much we have been applied or given in the problem is 60 volts. The developed voltage across this resistor is how much? 18 volts. The developed voltage across this 9 ohm resistor is how much? 27 volts. What is the voltage across this 5 ohm is 15 volts. So whether we are done correct or not, we are going to apply Kirchhoff's voltage law. So current is leaving. What is the leaving polarity of the voltage? Plus 60 volts. Okay, current is leaving. What is the leaving polarity of the voltage? Minus 18 volts. Current is leaving. What is the leaving polarity of the voltage? Minus 27 volts. Current is leaving. What is the leaving polarity of the voltage? Minus 15 volts is equal to 0. Therefore, 60 volts is equal to 18 plus 27 plus 15. So when you solve it, applied voltage is nothing but the voltage across three different resistance. This is how we are going to verify Kirchhoff's voltage law. Okay, so source voltage is equal to load voltage. So hope you are able to understand. Just remember the formula of voltage division rule is total voltage or source voltage multiplied with the resistance where voltage is required. So same resistance where voltage is required. So this is nothing but I require across 6. There's nothing but into 6 divided by 6 plus 9 plus 5. So 60 into where I require is 9 into 9 divided by sum. So 60 into where I require is 5 divided by 6 plus 9 plus 5. So this is how to understand a problem or how to solve. Hope you are able to understand the problem. So if you feel the content is useful, please like the video, share with your friends, and if you have any doubts, let me know in comment section. And if you're watching the channel for the first time, subscribe to the channel with the name KV Tulasiram. This is a free channel for the development of students and faculty. So thank you for watching. Yours obediently, Ram.